Hi there, my name is Andrej. I manage a company named Fluxair Environment Solutions. We do HVAC diagnostics, improvement and restorations, and also sheet metal repairs and installations. Today, I'm going to be talking about residential dryer venting. About 90 to 95% of the systems out there experiencing some kind of problems, and the range is all the way from small deficiencies to completely unusable system. Even with the brand new, the best dryer in the world, if it's not matched with the proper functioning exhaust systems, it's pretty much useless. We've been getting a lot more calls now with people buying brand new dryers, and they come with the safety features and all the alarms and codes. So what happens is that people are happy installing new dryers, just to find that once it's turned on, a few minutes into it, the error message pops up and the dryer stops. So the thing is that the dryer is only good, it can only push as much air as the exhaust ductwork will allow it to. So that's the importance of the actual venting or exhaust system. Going back to the principle of drying, just to touch base on that. Wet clothes are put in the dryer, water is still in a liquid shape. The dryer applies heat and the tumbling motion in order to accelerate evaporation, so water changes the state from liquid to vapor. It gets transferred to the air, and then the dryer fan expels that moist air through the system out. Again, I'm going to stop at word out, because even though it is mandatory, and every once in a while we still find some dryers to exhaust indoors, which has so many detrimental effects that it just it's a big no-no. So all these problems that I mentioned earlier can arise from three different stages: design, installation, and normal use or maintenance. In the design stage, there is hardly ever a problem there. If the system is being designed, the chances are it will be designed properly, and by the codes, there's very little problems that can arise there. Now moving into the installation phase, it will vary quite a bit. If we talk about new build, so if the system is installed in the early stage of construction, when there's very few elements and very few other things installed, there's a lot of room available, and ductwork can be installed as close as possible to design specs. On the other hand, if the system is installed at the later stage of construction, when there's already electrical, plumbing, and all the other elements in there, plus there may be some changes in the framing and even drywall, then the situation changes quite a bit. Now you have to run your duct around all these obstacles, and that changes the length and efficiency, and overall can turn one efficient system into very inefficient. Third point is normal use. So let's say that the first two stages are done properly, so you have a good properly functioning system. It's in normal use, so every system will need, no matter how efficient, will need eventually some cleaning. In order to clean the dry exhaust system where the lint is adhered to the surfaces, you need some kind of tools that are required to dislodge. So there's some kind of aggressive method in use in order to make the ductwork clean again. That means force, and again, it's all about the tools you use, technique. Right now we're talking about concealed ductwork behind the wall. If it's not fastened properly, or if proper materials are not used, this cleaning can do a lot of damage. Could disconnect the ductwork, can make holes in it. It can render the system completely unusable. Another cause, which is quite often too, is restorations done somewhere else, not with the system itself, but on other systems or any other part of the house that are actually close by or near the venting system. So it could be accidental damage to the ductwork by crushing it, hitting it, or even cutting. So in order to sum it all up, so let's talk. There's standards. We have international residential codes. We have here in Ontario, we have Ontario Building Code that define the system, materials, length, clearances, and installations. However, this is all in paper, and what we find in the real world is very, very far from the ideal and from these codes and whatever it's written in the book. Okay, so let's look at the exhaust system itself. I split it into sections, and we'll start right at the beginning on the dryer side. Let's start with the connection from the dryer to the concealed and the solid duct, and it's called a terminal connection. And most of the time, the flexible hose is used for that connection simply because it's the ease of installing. Most of the time, dryer needs to be pulled out of its spot. The duct is connected, and then the dryer is just pushed back in. We're gonna start at the low end. So the lowest quality product. Actually, this is not even the lowest quality product. There's one even below this, and that is white vinyl hose. I didn't want to bring it here. I'm just going to mention it. It's against the codes, and if you ask me, I would make it illegal anyway. But I had to mention it. So the next step up, if you can call this step up, is the foil. It's a foil flex hose. As you can see, it stretches quite a bit. It's very flexible, so it's extremely easy to work with. And that's the main reason why this type of hose is used for a dryer connection. And you just stretch it, you connect the dryer to the wall, and then push the dryer. Once this thing is pushed behind the dryer, you have absolutely no control over it. You don't know what it's doing and how it's going to fit. Again, the ideal would be if it would at least compress like that. And this is, even in the best case scenario, if it would compress in a straight line, you can see once this is compressed, the inner diameter reduces. It's not a 4-inch anymore because the material, the foil, actually folds inwards. So it reduces the diameter itself, without any foreign material. So the only time when this would actually be efficient as possible is when you stretch this, because after it's stretched, the inner surface of it also stretches, and it's as smooth as it gets. Definitely a lot smoother than when it's compressed. But again, this thing usually it's stretched only when the connection is made, and then after the dryer is pushed in its position, it's either compressed like that or entangled completely crushed. This can easily crush and change the shape. So this is the Achilles heel of any dryer system. Let's move up to the next product, which is aluminum, solid aluminum flexible hose. It's flexible, not as flexible as the foil, of course. It's definitely more solid. If you look at the inner diameter, it maintains the 4-inch, even when it's compressed and stretched, because the grooves are a lot shallower. So, but again, even though it's better, still the internal surface of it is very rough. The grooves, this creates a lot of resistance to the airflow. And there is also another drawback, and that is strength. So it's definitely not strong and stiff. So if dryer is pushed against it, this can easily get crushed. And again, so when something like this happens, this causes tremendous resistance to the airflow. Plus, it's gonna start catching lint in no time, and it's definitely not a good solution. Let's move to the next step. If you ask me, this is just the top of the line flex hose. It doesn't get any better than that. If you have to use the flex hose, definitely I always use this. So as you can see, it's reinforced foil, a lot stronger than tin foil. It stretches, it compresses, but it maintains the shape a lot better. If you look at it, inner diameter is 4-inch, and surface it's definitely a lot smoother. It's a lot more flexible than aluminum. It's not as flexible as foil tape, but again, if you already have to go with the flexible hose, this is the way to go. And it's got the strength. As you can see, you can push it and it just will not crush easily. So if you have to use a flexible hose, this is the way to go. A couple of pictures. This is 2 examples of typical site when you look behind the dryer. There's these 2 on the top. So this is very typical. So dryer is pulled up, connected, pushed back in, and this hose, it just compressed here. So again, you can imagine that the resistance here, there's a turn here and it just compressed, and we don't even know what's going on underneath here, but definitely not good. In this case, you can see the dry outlet is offset a little bit. So, and the hose is pushed down, and here I'm surprised that there's any flow, any air going through this at all. This is completely compressed and crushed, and so like again, right out of the dryer, the air hits this thing, and well, you can imagine what that does to your drying time. And we haven't even reached the main system yet. Okay, so that's for the terminal connection. I'm just going to mention that all these, and this is what we would do whenever there's access to the dryer from the side or from anywhere else. I always tend to make the connection solid. So installing even the elbow with the offset here, or a solid metal pipe here and here, anywhere. So whenever there's a possibility, a solid metal pipe should go right to the dryer, so no flex at all. If there's a need for flex, it's got to be made as short as possible. Even a few inches, it's better than installing like the whole length. Okay, that would conclude the section with the terminal connection. So let's move on. So from here, as you can see, so now the ductwork, again, this is, it's not always the case, but in most other cases, the duct goes into the wall, and then now we can't really see it anymore, so we don't know where it's going. We can only assume where it's going. So it's all concealed. Concealed ductwork, again, codes require it to be solid metal. So, but it must not be any type of flexible hose. Anything else but solid metal is against the code behind the walls. This is just a short piece of duct section, like solid 4-inch duct. I can clearly see that the surface is nice and smooth, so this creates very little resistance for the airflow when the air moves through it. Concealed ductwork consists basically of a solid metal straight sections and the fittings, which are primarily the elbows, whether it's 90, 45, or any other angle that would be required to run the duct towards its exit point. If it's solid metal duct, this is the best we can do in terms of friction. So solid metal duct. Now let's move to the fittings. Again, we'll start at the bottom. This is a standard sectional 90-degree elbow. It's used in most of the systems and just everywhere, every dryer, not just the dryer, but all the 4-inch systems and larger. What it does, it changes the airflow, enters here and exits here, so it changes direction. But again, you can see it's a very short radius, so the air makes that turn very sharply. So the sharper the angle, the more resistance it will make. So just the angle itself, the distance being so short, that's going to create resistance itself. And plus, there's also these grooves that actually come from the section joints. Those also create additional friction, plus they also like to collect lint. So for many reasons, this elbow is anything but efficient. Again, it's standard, everybody using it. So and this is what we find in the systems. This can be improved by using this type of elbow. As you can see, it's quite a difference. The radius itself, it's a lot longer than you can see. So no sections, it's a smooth surface inside, it's a nice and straight run. So the air enters here, leaves here, it flows smoothly up. There's no resistance to the turns. There's nothing in it, no grooves, nothing that would slow it down further or catch a limb. So this is definitely a huge upgrade from that standard elbow. Unfortunately, if you look at you see the size, it's larger than the sectional elbow, and that's its major drawback. Especially if you're doing retrofit and you do repairs and replacing fittings in the already existing setting. Quite often there's simply not enough room to fit this fitting, this elbow, into the existing system because of many reasons. So that's a major drawback. So if you don't have enough room to go with this kind of elbow, you're just forced to go with the small sectional elbow. There's one thing I forgot about that, and that is the fact that it's the sections themselves. So each section moves individually, it turns individually, so you can actually change the shape of and the angle of the elbow. So if you can see that, you can actually make an offset, or you can change the angle by pretty much from 90 to 0 degrees. You can choose, you can make any angle you want, and that's a convenience of this. However, most other systems use like 90 or maybe 45 degree turns anyway. So you may need this ability or capability of the elbow once every blue moon. So again, this still does not justify all the drawbacks that it brings into the game. The long radius turn also comes at 45 degrees. So if any smaller turns are needed, 45 degrees will do it. If there's any angle between that, the combination of 90 and 45 can actually do the job by just turning it and getting it to do desired angle. So there's always a way to go, given you have enough room for it. One more step up. It's pretty much the same thing. It's another long radius, even longer radius turn. So again, now you compare these two, you'll see the difference. Less resistance, but as you can see, this is huge and really requires a lot of room. So this can pretty much only be installed when there's a new installation or the ductwork is exposed with nothing in the way. So this is the major drawback when installing this. If you want to really put it in the system, make it really efficient, you need room. You need room for that. Okay, so that would conclude this section of concealed ductwork behind the walls. So again, I'm just going to repeat, it all must be solid by the codes. Everything that's hidden behind the wall must be solid, no flexible hoses whatsoever. After the duct runs through the wall and ceiling and floor cavities, now it's got to penetrate either the wall, or if it's vented through the roof, it's getting into the attic and up. So let's remain with the attic. So this comes out of the wall and from the attic floor to the roof itself. It's got to, if it's a vented attic, so that means that the environment in the roof attic is not conditioned. That would require the duct to be insulated to prevent the condensation. Again, it's got to be solid and insulated from the dry bottom to the roof itself. We've been finding a lot of flexible hoses just lying on the attic floor and then just doing all kind of curves, and very, very inefficient. So all solid. The ideal ductwork is solid from the beginning right to the very end. Okay, so that's the attic. Let's continue with the penetration. So if we're already at the attic, so that duct going to the roof, of course the hole in the roof, it should be as close as possible to the diameter of the pipe in order to make a proper seal. And of course, I don't need to mention that the connection's got to be made to prevent leaks. When it comes to the walls, things get a little bit more complicated because of there's many layers in the external wall that you have to go through when drilling a hole for the duct to exhaust out. From the different type of claddings, brick, you got stucco, you got vinyl siding, you got all kind of siding, so you have to go through that. Now you're bringing it further in. You got all kind of sheathing, your plywood, and you got drywall, but then there's barriers, there's a vapor barrier, there's air barrier, there's insulation, there's a lot of layers that you have to go through to penetrate the wall. The goal is to make that hole as close as possible to the 4-inch, so once that duct is pushed through that hole, the gaps between are minimal, and of course, once it's in, it's got to be properly sealed. You really don't want to air or anything else using the gap around that and prevent any leaks. Also, the duct just before getting through the wall, 3 to 4 feet of it should be insulated because it's a metal duct, so it conducts the heat. Either warm in the summer or even worse in the winter. So when it's -20 outside, that duct gets really cold, and it gets cold pretty far inside the house. So you really need to wrap it into insulation to prevent the condensation inside the house. Okay, so now we're on the outside wall, and all we gotta do is just to finish the system. Okay, so we're at the external vent. The job of that vent is basically to allow the air that dryer pushes out to allow it out. Once the dryer is off, to close and to prevent the backdraft. So to prevent the air from out to come back in, and also to prevent any pests or any animals from entering the duct. Let's start with the plastic vent, same as with the other fittings. Many different models, types, and materials, like the plastic materials on the market. This is one of the better ones, and as you can see, so they come. These are louvers, and they open. They open when the dryer is running. The air blows through it. These open and the air blows out. As soon as the dryer stops, they close. Well, again, so they're plastic, so they're very light. They're actually quite prone to being stuck because of any lint, or when it accumulates here anywhere along this, it will just tend to keep these flap open a little in the beginning, a little bit, and then as the lint accumulates, it will just keep getting more and more open. Of course, allowing the air to go back in, and the animals, it will allow them access to the duct itself. This is one very important point. This particular vent, as you can see, it came with a screen which can be used for washroom exhaust or any type of other exhaust. However, dryers, absolutely no, it's against the code to put the screen on any dryer element, any dryer fitting, so no screens whatsoever, and you'll see why later on. This comes in, dryer runs, these open, dryer stops, they close. And also the material itself, PVC or any type of plastic, it's just it's got its durability, you know, and it's quite limited, and it's affected by the weather a lot, primarily UV lights. These, no matter what, and no matter where, when, they're gonna get brittle, and eventually they will fall apart because just due to regular use. Move to the next step. So let's say that we're, for one reason or another, we're forced, or we want to use the plastic vent. So at least what we can do, there's not much we can do about these and the airflow. However, what we can do is to prevent the pests and animals to get in the duct. So if for some reason this does damage and these flaps remain open, no animals will get even close to that to the duct. And this is done by installing the guard over on top of the vent. These also come in different shapes and materials. I'm not a fan of it, but if you really have to use it, again, at least use the metal. So this is one of the top on the market. It's very easy to install, and it comes right over the top of the vent. The high quality metal guard. It's got a feature that actually the bottom can open, and you can access the vent for cleaning or any other reason. So you don't have to remove the actual guard. And as you can see, these bars are very, very thin, and they're round, so they will not catch lint when it's going over. So unlike some of the plastic guards that have these square, and they very easily catch lint. Next step is a full metal vent with a cap. Cap does protect the vent from the weather, whether it's rain or high winds, and also the animals. It does have, as you can see, it does have a backdraft damper inside, which is definitely it's a mandatory in each vent, each exhaust vent. However, there's few elements in it that will catch lint eventually. So. And that's why it is definitely not my favorite. It works well with the washroom exhaust or any other exhaust. It's the problem with the dryer exhaust is lint, because the air coming out through all these elements carries lint with it, and lint really likes to get caught on whatever is in its way. There's also a very, very important point, again, regulated by codes. No screws should be used in a system at all. So nothing can penetrate the duct inwards, because whatever it's inside the duct, even the small screw, eventually it will turn into a ball of lint, and it's gonna create more resistance. So no screws within the dryer system at all. This is definitely my favorite. It's a full metal vent. It's designed specifically for dryers. As you can see, it's got one big flap, solid metal. It's got weight on it, so it will allow the air to come out. It will firmly close once the dryer is not in operation, and it will not allow either air or pests to go in. And again, another really nice feature about this, it just comes in, it's a two-part. So this is a base that gets installed onto the exterior wall. It's fastened in and sealed properly. So this is the part that's permanent. This part, actually vent, it comes out, it's fastened by two small screws at the bottom, and it fits really nice and snug. And if you, for any reason, you need to clean the duct, you need to access it, do whatever, you just remove it, and you have access to the duct. You got a clear opening there, beautiful for cleaning, for any other purpose. The vent itself, as you can see, even when you pull it upside down, the flap will not open, because it's held by two little magnets here that it really keeps it firmly closed. And another thing, you can see the flap is pushed inwards. It's nicely embedded into the vent frame, so nothing can actually open. So no animal can actually come and open the vent. So it's just a great design, and it works well. Again, the metal itself, it will outlast any plastic vent by far. And this is if it's not physically damaged, and if it's maintained properly, this is basically a lifetime vent. Let's move to the roof exhaust vents. My favorite, and this is actually the only vent that we install, is the solid metal product. You can see it's nicely curved. Again, it's designed for dryers, and they paid a lot of attention to every single detail, and primarily efficiency. It's the same product, it's the same manufacturer. They do the vent and the flexible hose, the top of the line flexible hose. So they do few products, but they're specifically focused on dryers. And even if you look inside, everything is curved. The flap opens. It provides nice curve for the air. Again, minimum resistance, and the seal is really nice. There's nothing can get in, the weather or animal or anything like that. And again, no screens. So this is a top of the line vent that will outlast the shingles on the roof by quite a bit. I don't have any other vents that I wanted to show you to compare it with this. However, I do have a few pictures of the vent that we took on a job. So if you look at this, well, first of all, here there's one thing that these three have in common: plastic, and plastic. This is another vent with the screen. It's just showing that what screen does. Why are the screens not allowed in the dryer systems? Because it's it's not a question if, but how soon they're going to get plugged. Okay, going back to the roof vents, you can see again plastic, and it really doesn't have an actual screen. It's very coarse. As you can see, it's almost a grate here, so 1 inch wide, and still look at this lint, how it's plugged solid. So there's no air going through this vent at all. So that means that it's either staying inside the dryer or it's finding its way out somewhere else. But it's definitely not going through the roof. Very similar example here. We got a different screen, which is a lot finer, metal screen. Again, the same outcome. It's plugged solid. So there's no air going through here again. And it really doesn't take very long for this vent to get into this condition. I mean, it's just unusable. And this is when the problem starts. So the air cannot get out. Now it's finding its way in, and guess what? Most of that air will go through the cracks and gaps within the ductwork, and it will end up somewhere inside the house, and obviously do damage there. Now, this is really funny one. This is the vent that we come across on a regular basis. It's a vent that's used for, again, primarily washroom exhaust. But I guess the contractors, they just buy a whole bunch of one type of vents, and they just install them for everything that's coming out through the roof. And as you can see, this right here, that's a very dense. And for this, my guess would be maybe 2-3 months, and you'll have this thing plugged solid. Now we're coming to the best part. You won't see on a video. However, I'm going to read it here. So it says, do not use this model for dryer venting. Imagine that. you're looking at the dry vent, and it says right on the vent, a big letters here, says do not use for dryers, and guess what? There's lint sticking out of this. So again, I don't know how many of these vents we came across and obviously replaced with the proper vent. So conclude the section about the dry system itself. So we covered everything from the dry outlet to the exterior vents.